Welcome, the learner, to another deep dive. Today, we're cracking open Kristiyan Velkov's book, Mastering React.js Interviews.
hmm
Now, don't let the interview angle fool you. This is
Mm,
packed with seriously useful knowledge for, well, anyone building modern web applications with React.js.
absolutely. Think of it as, a guided tour through the essential landscape of React development.
Yeah.
We'll be picking out the crucial bits, from keeping your apps secure and accessible to leveraging the power of TypeScript, navigating routing, and managing your application state effectively.
Exactly. We're also going to explore how to fetch data like a pro, get acquainted with GraphQL, understand why testing is your best friend, optimize for peak performance, and finally, get your React creations deployed smoothly.
Right.
Our mission is simple: to extract the core insights, giving you clarity and those aha moments without getting, lost in the weeds. Okay, let's dive right into security and React applications.
Okay, so a really critical security issue we need to be aware of is something called cross-site scripting, or XSS.
XSS, right?
This is where attackers can sneak malicious code into a web application. And when other users browse that app, this code runs in their browsers.
Uh-huh.
This can lead to some really nasty outcomes like stolen login details or even impersonation.
That's definitely concerning. So how does React, right out of the box, offer us some protection against this?
Yeah, React's default way of handling JSX is a big help.
Hmm.
It automatically makes sure that any dynamic content you're rendering within your JSX is treated as plain text, not executable code.
Ah, okay.
So if someone tries to inject a script tag, React will just render it as harmless text on the page.
Right.
However, you still need to be vigilant, especially when you're dealing with user input. Always sanitize any data a user provides before you render it, particularly if you're not using JSX directly.
Right, because user input can be all over the place.
Exactly. Understanding this prevents you from building applications where user data or even control of their accounts could be compromised through seemingly innocuous interactions.
Now, there's this dangerously set inner HTML attribute I've heard can be a bit of a foot gun. What are the key risks there?
You're right to be wary. Dangerously, set inner HTML lets you directly set the HTML content of an element from a string.
Okay.
While it has legitimate uses, like displaying rich text from a trusted source, it completely bypasses React's built-in safety net.
Ah, okay. It just ignores the safety checks.
It does. So if you use unsanitized user input with this, you're essentially open a direct line for XSS attacks.
Right.
So it's something to use very sparingly, and only after you've thoroughly cleaned the input with a dedicated sanitization library. Think of it as a last resort, and only when you really know exactly what you're doing.
Got it. Handle with extreme care. Now, let's think about keeping sensitive information under wraps. Where should we be storing things like API keys and authentication tokens in a React application?
Okay, the book emphasizes the importance of using environment variables for API keys.
Mm-hmm.
These should live in .env files that you explicitly exclude from your version control system. Never check those in.
Right. Definitely not.
This way, your secret keys don't end up in your code base and can be configured differently for your development, staging, and production environments.
Okay.
You then access them in your React code using something like process.env.react_key, depending on your build setup, of course.
Okay, so environment variables, keep those keys separate. What's the recommended approach for handling authentication tokens?
For authentication tokens especially, HTTP-only cookies are, well, often the way to go.
HTTP only.
These cookies get sent along with HTTP requests, but crucially can't be accessed by client-side JavaScript. This significantly reduces the risk of XSS attacks stealing them.
Ah, because the script can't see them.
Exactly. In-memory storage can also be used for temporarily holding sensitive data, but you should avoid persistent client-side storage, like local storage and session storage, for anything truly sensitive.
Why are local storage and session storage considered risky for sensitive data?
Well, because they're directly accessible by any JavaScript running in the browser.
Oh, right.
So if an attacker manages to inject malicious code, they could easily read and steal anything stored there.
Makes sense.
It's also vital to remember that you should never expose private API keys directly in your front-end code, ever.
Right.
If your React app needs to talk to a protected API, the best practice is to have a secure backend act as a middleman, proxying those requests.
Yeah.
The front end shouldn't hold the ultimate keys to the kingdom, so to speak.
That's a really crucial distinction. What about HTTPS? We see that little lock icon all the time. Why is that so vital for React applications?
Oh, HTTPS is fundamental. It encrypts all communication between the user's browser and your server.
Right.
This stops eavesdropping and tampering of data as it travels across the internet, protecting sensitive information like login credentials and personal details. It's a basic security layer for any modern web application, and that includes those built with React.
Absolutely essential. Now, another term that comes up in security discussions is cross-site request forgery, or CSRF. What exactly is that?
Right, CSRF. It's a type of attack that takes advantage of authenticated users.
Yeah.
So imagine someone is logged into their online banking.
Okay.
An attacker could send them an email with a seemingly innocent element, like an image. But when the browser tries to load that image, it actually triggers a hidden request to the bank, maybe to transfer funds to the attacker's account.
Oh, wow.
Because the user's already logged in, their browser automatically includes their session cookies with this forged request, making it look legitimate to the bank's server.
Oh, that's sneaky. So the bank thinks it's a real request from the logged-in user. How can we protect our React applications from CSRF attacks?
The book outlines several key defenses. CSRF tokens are a common method.
Okay.
These are unique, secret tokens generated on the server for each user session. These tokens are then included in forms or with AJAX requests. The server then verifies this token when it receives the request to make sure it actually originated from the application and not, a malicious third party.
Got it.
Same-site cookies are another important defense. By setting the same-site attribute of your cookies to strict, you prevent them from being sent with cross-origin requests initiated by other websites.
That's useful.
And finally, implementing strict criteria, cross-origin resource sharing policies can help by controlling which other domains are allowed to make requests to your application. It's really all about building layers of security.
Layered security makes perfect sense in this context. Okay, let's shift gears now to something equally important, making our applications accessible to everyone. What exactly is web accessibility, often abbreviated A11Y, and why should we care so much about it?
Right, A11Y. Web accessibility is about designing and developing websites, tools, and technologies so that they are usable by everyone, including people with disabilities.
Great one. Okay.
And this covers a wide range of abilities, including visual, auditory, motor, cognitive, and neurological. It's not just about meeting legal requirements, though that's important. It's fundamentally about inclusivity and providing a better experience for all your users.
So it's about making sure no one is left out from using the web. What are some specific reasons why web accessibility is so crucial?
Well, the book highlights several key reasons. Firstly, it's about inclusive design, right? Ensuring that individuals with various disabilities can perceive, navigate, and interact with your content. Secondly, in many places, accessibility is a legal requirement, like the ADA in the US and the Web Accessibility Directive in the EU. Compliance helps avoid legal issues.
Good point.
Thirdly, accessible websites often have improved usability for everyone, even those without disabilities. For example, clear keyboard navigation can benefit users who just prefer it for efficiency.
Sure, I use that all the time.
Exactly. Fourthly, accessibility best practices like semantic HTML and alt text for images often align with SEO, improving your search engine rankings.
Oh, interesting connection.
And finally, by making your website accessible, you're simply reaching a wider audience. It just makes good sense.
Those are all really compelling points. Now, I've heard of WCAG guidelines. What are they, and what are the main principles behind them?
WCAG stands for Web Content Accessibility Guidelines. Just a reminder, that's the internationally recognized standard for making web content more accessible. The current version, WCAG 2.1, is built around 4 core principles, often remembered by the acronym POUR.
POUR. Okay, that's a handy way to remember it. Can you break down each of those principles for us?
Certainly. Perceivable means that information and user interface components must be presented to users in ways they can perceive.
Right, like seeing or hearing it.
Exactly. This includes providing text alternatives for non-text content, like images using the alt attribute, offering captions or transcripts for videos and audio, making content adaptable to different presentations, like how a screen reader reads it, and ensuring sufficient color contrast for readability.
Okay.